Okay, here's an example of a two sample t interval or difference, trying to estimate a difference of two means using a t interval. And we're going to go ahead and do that because, well, that's what the situation calls for here. If you read the scenario, and again, assuming your homework again is going to have something like this written up here that we want a confidence interval for the difference of population means using the t-distribution with unequal variances. And we'll get into what we do with equal variances here a little bit later in a different example, but I'll label this as such. So you have two independent random samples here in this scenario, and they're looking at number of tomatoes yielded in a plot, similar plots, and I guess this engineer is developing soil additives. He calls additive one and additive two. And the goal here, I guess, is to get a higher yield from, see which one's better, yields more tomatoes. And so what we have to do in order to find the t interval, I kind of already had here just to save a little bit of time, everything in. These are our results right here. And you could see again the net, net results for doing that is just, or the way we're going to accomplish that is simply just going ahead and, looking over here and what we have typed in. Okay. So again, we've got to type in that information here. Don't get confused with this. This is for the Z information, which is over on the other side. Okay. So we're going to go ahead and we'll go through one of those here, or we already did go through one of those in a different scenario, but here we don't know those standard deviations for the population. All we have are the sample data. Okay, so that means we got to put in the sample means and also the, excuse me, right here, the sample means and the sample standard deviations and the sample sizes. Now, they don't give you those numbers directly, so I'm just going to go show you real quick here because there was a lot going on in this problem here to just get the information in here. And one of the ways you can do this is kind of a nice feature of ALEKS is you can send this data to the calculator. So in other words, I'm going to send the first group over here, and that's just taking all these numbers and typing them in here. And then that way, all I do is click on the mean button and press my enter, and I'm going to get the mean for this particular one over here, which for some reason that doesn't seem to, let me try that again. All right, so I'm going to send additive one. I might have had a different number in there, and then I calculate the mean and hit enter, and there's my 119. I probably had an extra number in there. Okay, so I put that in for 119 here for my mean, and then I'm going to go ahead and do the standard deviation just like I did with the other one. So I should get an 18.4 here. So I got to clear everything out, make sure I do that. So let me send over additive one and calculate the standard deviation of that. I press my enter button, and there's my 18.4. Okay. And then I do the same thing over here. I don't know if I need to demonstrate that, but I just choose to send the other set of data over, calculate its mean, and hit enter on my calculator or on my keypad here. And here's the 133.308. Okay. So do the same thing for the standard deviation. And then I have my sample sizes here written in. Okay, 12 and 13, because there's 12 numbers here and 13 here. And then, since I'm just doing the confidence interval, all I had to do is just, come over here and look for my lower and upper limits. And there's my negative 47.36. And I guess, we wanted 2 decimal places here. And here is my 18.74 for my upper limit. Okay, so if I get out this again, we rounded to 2 decimal places here. So again, we got to make sure that we do that correctly, and that's just a matter of paying attention to this. So that's how you do a confidence interval for unequal variances. We don't know what the variances are, so we go by default to this particular value right here, typing that stuff in. If we would have known the variances or the standard deviations, we would have used the z interval to calculate that. But since we weren't given that information, all we were given the data was this. Now, some of these questions, they might not give you this in the table format. They actually might just give you this in the body of the scenario. And you would just, again, have to type all these numbers in there, but they would just be given to you up here. Sometimes, as in this example, you got to do a little extra legwork. And again, that could be accomplished by this calculator here, okay? So I think that's kind of a little nifty feature that they have here for this type of problem, to go ahead and analyze the data. That way you don't have to spend all that time typing that stuff in. And I know, from past experiences, students, if you enter the data in wrong, obviously that's going to throw the means off. If I would type 123 instead of 132 and so forth, you can see that that's going to obviously affect these numbers, which in turn will affect the confidence intervals here. Okay, so that's one thing to keep in consideration there. All right. Also, again, just like I did before, what we're saying is that if we're estimating the difference, what do these represent? That's the average yield. So we're saying that the yield in additive one is going to be anywhere from 47 tomatoes lower to 18 tomatoes, or roughly 19 tomatoes higher than additive two. Okay, so that would be one way of comparing those things, which you're saying, well, wait a second, then there's really no difference between those. It's just going to vary from sample to sample, and that reasoning is correct. And if you actually looked at the p-values that we're getting over here from say a two-sided test, if we were looking for one, just there being a difference, that's a 36%, 0.36 p-value. There would be no reason to reject the null hypothesis that the two means are equal. Okay, so there's this confidence interval here, again, is just kind of reinforcing that there's really truly no difference between the yield in these two additives. Okay, so at least in that comparison, there's no difference between those. So all right, so that's one using a t-interval with unequal variances, or variances we just don't know. And so pretty simple process.